This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program, and in the yesterday's session, what we have seen, we have gone through with MapReduce basics. If we are talking about MapReduce, that is nothing but the combination of two words, mapper plus reducer. And in yesterday's session, what we have seen, like how this particular MapReduce is functioning. If we are having a particular file, then how a particular file is being divided into blocks, and those particular blocks are given to mappers. MapReduce basics. So we have gone through with MapReduce basics. So if a particular file is there, and the file is given to splitter, and splitter is going to split this particular file in blocks, and then we are having record reader, then we are having a bunch of mappers. Okay, and mappers are like working on to top of that particular file, and then we will be able to get intermediate output. That intermediate output is given to say combiners, which are also working on to mapper side known as mini mapper, and then we are having partitioner, and then finally we are having reducer. Okay, so over here, like there are certain things that we need to keep in our mind. Number of mappers, how many number of mappers we can have, that is depending upon the number of blocks, or what I can say, number of mapper equal to number of blocks. Okay, one node can handle many mappers. It might be possible like we are having thousands of blocks, and we are running with 4 node cluster, 5 node cluster, or 10 node cluster. So those particular blocks are divided among the machines or nodes based upon the configurations of node, and then we will be able to get the output. Number of mappers equal to number of blocks what we are having. That is generated by splitter. A splitter is going to convert the data in blocks. Say what we are having blocks over here, and then blocks are given to record reader, which is adding a random number, the number addition. Okay, so reader is going to add a random number, then mappers are going to provide intermediate output.
Basically, this record readers convert it into key value pairs, na?
Yes, key and value pair, because the
Okay.
mappers are not able to understand the data. Okay, it is able to understand key and value pair only.
Okay. Okay.
Plain data cannot be handled by mappers. Mappers are able to handle the data in key and value pair. So that's why like we are having a need of a person who can generate the incoming data blocks in key and value pair. So that's why we are having record reader. Okay, so mappers or combiner, that is what I have mentioned. These are running onto the same machine. Okay, and mapper or combiner, not mappers. So mappers like can be running onto the different machines or nodes. So we will get intermediate output over here, and then the partitioner, it is deciding which key move to which reducer. Which key moves to which reducer, that is decided by this partitioner. Then finally, like what we are having reducer, and reducer is going to provide me the final output. Final output. Okay, so in order to understand these particular things in more detail, I'm going through with certain examples. So say what we are having certain data, and in this particular data, I'm having date and time and say temperature. Temperature. So these are the three columns what we are having in a particular data set, and date, time, say what I can mention, say 18 Feb, and 18 Feb, and say the reading has been taken at 9 a.m. Okay, 9 a.m. and the temperature is say 18 degree. 18 degree. So this is one reading. And similarly, like we are having the data of different dates, what I can mention, say we are having the reading of say 15th Feb, then say 16, 17, 18, 16, 17. We can have multiple records of a particular data. Okay, in the same fashion, say we can have multiple records. And multiple records, say 9 a.m. and then say 10 a.m. then say 11, 12. In this particular way, say we are having the data of certain dates. 9 a.m. say 11 a.m. Okay. Then what I can say, 1400 hours, then 1600 hours. I'm taking certain data so that like I can walk you through with certain example. This is the raw data what we are going to prepare. So 1800 hours and 16 Feb say 1200 hours. And we are having certain readings. Let me create certain dummy data. Okay. Okay. So this is the data what we are having, and we are running with say four mappers, or like we are having in another words, in order to simplify this particular stuff, what I can say, I'm having this particular data, and I'm running with four machines. A four node cluster is there. Let me insert say four node cluster. So I'm having four node cluster, and we are having four blocks, or I'm going to divide this particular data in four blocks. So say block 1, block 1, block 2, block 3, block 4. So this is a block 4 information. In this particular way, blocks. So this is the initial data set what we were having, and what I have done, I have given this particular, or you can say this is a particular file, and this particular file is given to splitter, and splitter, it has done what, it has converted this particular data in terms of blocks. Okay, so block 1, block 2, block 3, and block 4, we are having this particular data. Now what we are looking for, we just want to find out the highest temperature of a particular day. The use case what we are going to discuss on top of this particular data, we just want to find out the highest temperature of a particular day. Okay, now this is say mapper 1, or you can say on node 1, on say node 1 or mapper 1, you can think in this particular way, say mapper 1, mapper 1, mapper 2, mapper 3. These particular blocks are given to mappers. Now, mapper, how the mapper will work, it is going to like apply a certain logic. We are the guys who are going to write down the logic for the mapper machines or mappers. So, like one block is given to one mapper, and what I have mentioned, number of mappers are equal to number of blocks in a particular cluster. So, with respect to this particular input data, what we are able to get, so on 15th of, you can say, Feb, the highest temperature what we are having, that is 21 degree. So what will be the outcome from mapper 1 after applying a certain logic? So what we are able to get, we will be able to get the outcome, say, the outcome what it will be. So first of all, like with respect to this particular data set, uh, how many columns I want to have? I just want to, or which are the columns that I need to take into consideration in order to find out the highest temperature of a particular day. So say this is the input to the mapper, and what is the output that I'm expecting from the mapper machine? What can be the output? What
Mm,
can be the
It
output?
it will give the date and time as well for the temperature 21.
But it might be possible, say, the required output is like I just want to have the the highest temperature of a particular day, not with respect to a particular time. Highest temperature of a particular day. Then why I need to like take this particular column as an output? I can uh, like have date and temperature only, and it will suffice my output.
Yes,
Right?
if we require
There is
only
no need to.
highest temperature only, then there is no need of time.
Okay, yes, that's what like I'm looking for. So the output, what it will be, say 15 Feb and comma and
21.
21. This will be the output from the
Yes.
mapper one. And this is nothing but in key and value pair, right? This is in key and value pair.
And value
And what
pair.
can be the input for the mapper? Like it is going to take these particular keys, okay,
Like
and it is
Ashok,
going to.
if for mapper one, if we have one of the entry for 16th Feb as well, then it will give
Then we
two
will be
key
having
value
two
pair, na?
output. I'm coming on
Yeah,
that
okay.
point. Over here, if you are
Okay.
able to see, we are having three inputs.
Yes, 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 yes.
16,
Okay.
17, 18.
Okay.
So, what is the logic? How the logic will work over here? It is going to keep the key and work on values. Okay. What I mentioned in previous session, like keep the key, keep the key, and apply logic on values. And logic can be anything, like greater than, plus, minus, okay, or we just need to add certain columns or add certain values in order to get the values, right? So keep the key and apply logic onto the values. Over here, I'm having these particular dates. So uh, say, huh, so this is the data. This is the data set, and with respect to say 50 16 feb, what we are having, 21, 19, 20, 21, 22, 19, 20, and 21. This will be say input to the mapper. This will be taken in order to apply the logic. The mappers are going to take these particular values. Okay, so with respect to these particular dates, what it is going to do, it is going to keep the key first, like shorting and all will happen. uh, it is going to keep the keys. So like mini mapper or combiner will work over here, and combiner is working onto the reducer logic. So it is going to short the data, and with respect to shorting, like it is going to like keep the 16 fab as a key, and then 21 and 22. So which one is higher, it is going to take the highest value. So this is the outcome. 16 fab, then 17 fab, we are having no repeated values, then 18 fab we are having no repeated keys. So this is the output with respect to the mapper2 machine. 16 fab, 17 fab, and 18 fab. Okay, so this is the output of mapper2. In the same fashion, the mapper 3 will work, and with respect to the mapper 3, it is going to provide me 17 fab 21. Okay, and 18 fab 21. So this is the outcome from mapper 3. And with respect to the mapper 4, what will be the output? 18 fab 21. That will be the output of mapper 4. So this is nothing but intermediary output. And what we are looking for, we just want to find out the highest temperature of a particular day. Okay, highest temperature of a particular day, but this whatever we are getting over here, that is not the final output. So what we just need to have, we just need to have a reducer, and this particular data is given to further reducer, and reducer is going to do what? Reducer. So reducer is going to take this particular data, and it is working onto the same logic, whatever we have applied over here. Okay, and what I can say, combiner. Say combiner. What I can say. So it is going to work onto the same logic. It is going to take the keys and work onto the values. Say for the 16, for the 15 fab, that is the single entry. That is perfectly fine. For 16 fab, we are having the single entry, that is perfectly fine. For
Ashok,
17 tab,
this column G is the output of the mapper only, na? Column G.
yeah, actually what we are having, these this mapper or combiner, these are running onto the same
Same
machine.
same machine. Okay.
Okay, so you can take it like if you are applying this particular logic onto the mapper, that is then it is fine. If you are adding a combiner and writing down that particular logic in combiner, that then it will be also fine. It
Okay.
depends on
Okay.
you. Okay, how you are going to write
Okay.
down the logic, we will see, like once we are going with practical. So we will try to see these particular things.
Okay.
So what I want to say, 16 fab, that is we are having single entry, and with respect to 16 fab we are having the highest temperature, that is 22. Then 17 fab we are having two entries and two keys. Okay, and with respect to two keys we are having two values. So 21 is the highest, so 17 fab 21 is the highest. For 18 fab, what we are having three entries, and 18 feb 20, 18 feb 21, and 18 feb 21. So 18 feb 21, that is the highest temperature for that particular day, and that is nothing but the final output. Final output. Okay, so what we are able to see over here, this particular task was requiring one reducer. We are we can't move, or we can't proceed without reducer over here. So this particular data require reducer, and what I have mentioned in yesterday's session as well, uh, like the reducer need is depending upon the type of data, or the task that you are going to perform with the pipeline. So if you are willing to perform certain operations, and just like as we have discussed in yesterday's session as well, like say if you want to find out the values or the users who are uh, spending greater than 300. So over there what we have seen, there is no need of reducer, and whatever the output we are getting over here, that can be taken as a final output, and those particular jobs are performant job, what we can say performant job, because over here from combiner or from mapper machines to reducer, the shuffling will happen, shuffling will happen, and over here the sorting will happen. So this particular shuffling is nothing but the movement of records among different machines. The movement of records is like given onto the switches, and that particular shuffling is the time taking process, and because of that, like it is going to add the latency. Now it might be possible, like you can reduce the load of reducer, so over here what we are doing, we have added uh, like the combiner over here, and combiner is working onto the same logic, the logic which has been applied over here, the same logic is applied over here, that's why it is able to offload reducer. Okay, so if we are not having say reduce a combiner at this moment, just try to think, so like what I'm going to replicate this particular data over here. Now combiner is there, combiner, uh, with combiner, what I can say, with combiner apps, now what we are having over here, we are like we are performing intermediary operations, and then we are able to get the outcome, or shuffling less amount of data is shuffled from here, but say if this is the if like we are not adding this particular combiner, and we are just moving with uh, the outcome, or the shuffling, say what we are going to do, say each and every record, that is we have not applied any logic over here, say 15 fab, let me mention, say 15 fab 20, 15 fab 18, let me upper output, I'm just going to provide you more details. So 19, then 20 and 21, okay. So over here, like we are trying to provide the output, like after converting it into the key and value pair, and just we are not performing any operation over here. So at this moment, like the entire data is transferred from mappers to reducer, so this shuffling over here, like we are transferring huge amount of data. You can think in this particular way, like you are having 4 lakh records, okay, 4 lakh records, and with respect to the 4 lakh records, you are just like performing, you are not going to perform anything, you are just like taking the key and values, and uh, then uh, then transferring it to the reducer for the final output. This is you can say the intermediary output that you have taken up, that you have written your logic in such a way that mappers are going to perform the very less operation. So over here, with respect
Actually,
to
Ashok,
like say,
here mapper is doing nothing.
yes, mapper is not doing nothing, because like we are aligning, uh, we are not going to perform what I mentioned, like
Okay.
we need to write down the mapper's logic, and
Hmm.
like we have written our code in such a way that mapper is not going to perform anything, it's just
Hmm.
providing the input in the required format to the reducer.
Okay.
Okay, so the main criteria, I have explained it yesterday as well. We must write down our code in such a way that mappers are going to perform the maximum task over here only. Okay, if like we are having 4 lakh record, then you can think 1 lakh records are over here, 1 lakh records are over here, 1 lakh over here, and remaining 1 lakh over here. 4 lakhs records are distributed among these 4 mappers. Okay, now previously say after performing operations, say we are having 200 records. Okay, after performing for the operation on 1 lakh data, what we got, 2 lakh record 200 records are there which are having highest temperature with respect to a particular day. Then those particular only 200 records will be shuffled to the reducer, and then reducer will work and we will be able to get the final output. This was the case once we were running with the mapper, or we have written our code in such a way that we are performing maximum of the task over here. We are leveraging the benefit of parallelism over here. But if we are not leveraging the benefit of parallelism, we are like we have written our code in such a way that it is going to perform only a very less task, and then it is going to provide the data to the reducer, and reducer will work on top of this particular data, and then you will be able to get the output. At this time, like, the shuffling will be more, and shuffling, that is nothing but the costly operation, movement of records among the nodes. Are you able to get, friends? Are you able to get the context what I'm trying to say?
Yes,
Yes,
yes, Ashok.
yes, Ashok.
Yes, Ashok.
Okay, perfect. So over here, what we have seen, the advantage of combiner. What it has done, it has done the intermediate. It has worked onto the reducer logic, and it has reduced the movement of records from mapper machines to reducer. So shuffling has been minimized over here. That is the costly operation. Being a developer, we need to think in order to minimize the shuffling. Okay, we must leverage the benefit of parallelism. You can think in this particular way. uh, you are having you are having 100 pupils who are working onto a particular task, and then uh, those particular persons are, say, performing certain shorting and all. Like raw data is coming, raw material is coming, they are performing certain filtrations or removing certain bugs and all. Then that particular data or that particular material, filtered material, is given to a team like of 10 persons, and then they are further like working on that, and finally you are getting the refined product. Now if all those 100 people are not working, and the entire uh, input or raw data or raw material is given to the 10 persons who are designed to work onto the filtered material, then they need to perform a lot of tasks, and at that moment we will not be able to get the benefit of all those 100 persons. Okay, so over here what I want to say, we must leverage the cluster in such a way that maximum task is performed over here, and uh, and the very less so that like less shuffling of records or less shuffling of data will be there, and the reducer which is working on to the monolithic way. Okay, so it has to perform very less amount, it has to work less, and we will be able to get the outcome with low latency. So that is the use case. Now it is fine, like we are having a combiner, and it is working onto the same logic on which the reducer is working. Try to focus over here. So we are having combiner in order to offload the reducer. Like if a person is resigning in an organization, then we are aligning another person who is going to take the responsibilities of that person who is resigning. So then if it is going to take, or in another words, like say if one person is heavily utilized and we are aligning someone to offload that person, then what we are having, we are adding say one more person, and who is going to perform the task which is performed by that particular user or person. So offload means the offloader is going to perform the same activities. The offloader over here, the combiner is the offloader of reducer. So offloader is working onto the same task or onto the same logic which is written for the reducer. Then it will be able to offload reducer. So over here we just need to write down the logic in such a way that it is able to fulfill the need of the pipeline. Let me give an example. So without combiner. Okay. So we are having certain records. Say certain records are there. Say 5, 4, 3, 2, 10. Then we are having, or you can say these are certain source. Source one, or we are getting certain data from files. Or file one, say, and file one, then splitter has worked on to top of that particular file, and splitter has splitted it into the 4 blocks. And the data what we are having, 1, 2, 1 and 4 and 2, 1, 10, then 3, 2, 3, 4. Okay. 1, 2, 3, 4. So just try to like for your understand, or for like provide you the detail, like we need to apply the same logic uh, by utilizing our mind. Okay, once we are working on mapper and once we are working on to the mappers, or sorry, combiners. So say we are having this is the data that is given to say combiner, and say we are having reducer over here. What I mentioned, reducers and combiners both are working onto the same logic. Now, now we what I mentioned, reducer and combiner both are working onto the same logic. The logic which is written inside the reducer, that is written inside the combiner. And these are designed in order to offload reducer. So whatever the logic that is applied over here, that is replicated inside the combiner, but that particular logic must be utilized by utilizing our mind. So say if we are willing to identify uh, the sum of the incoming numbers. So incoming numbers, say at this moment the sum is what, the 24. So what it has done, it uh, what is the way, like if we are giving all the numbers, if we are performing the shuffling, then reducer is going to do the sum, and then we will be able to get the final output. So in order to offload the reducer, what we have done, we have added combiner, and combiner is going to offload reducer. So what it is going to perform, say it has performed the sum over here, and what we are able to get, we are able to get intermediary output, that is this much. And now these particular records are transferred from here to here, and then we are able to get the final output. Okay, so combiner is utilized, and the logic is to perform the sum on all the incoming numbers. So these are the incoming numbers, and combiner has done the intermediary operation. It has calculated the sum, and then now these particular numbers 24, 9, 15, and 10, these are transferred to the reducer. Only four numbers are transferred. Previously, like we are transferring this much reduce numbers. Okay, 16 records were transferred earlier, and now we are transferring four records only because we have added combiner, and combiner has performed the intermediary operation. It is performing some, so it is also performing some. Same logic has been applied over here. That is perfectly fine. Huh? So outcome is 58, and if we are adding, so we are getting 58. Huh? That is perfectly fine now. So sum is working perfectly. The output from reducer, that is the same. If we are like allowing or adding combiner, so with combiner or without combiner, the output is same. At this moment, what we can say, combiner has offloaded the pipeline. Fine so far.
Yes,
Fine
Ashok.
so far.
Yes,
Okay.
yes, yes.
All of you friends, I want the buying from all of you.
Yes, Ashok. Yes.
Okay. So the sum is working perfectly. The logic, like over here we are performing the sum, and uh, by adding combiner we are able to get the same output. If we are like moving these 16 records, then we are getting 58. And now if we have added combiner and moving four records only, shuffling four records only, let me use a specific word. If we are shuffling four uh, records, then also we are getting the 58. That is fine now. So sum is working perfectly. Sum is okay. Now if I want to find out the max, so in order to find out the max, let me perform the operation max of this. Sorry. Now I want to find out the maximum of the incoming numbers. So mhm. Okay, so at this moment the max is this one, the max is this one, the max is this one, and the max is this one. And these four records are given to the reducer, and reducer is also having the same function max of all of these. So, and also we are getting the same output. So if we are like uh, if we are having a look of these particular number, the maximum is 10. And by transferring all 16 numbers we will be getting 10, or by transferring these four records we will be getting 10. That is perfectly fine. It means like we can have the same logic, max or sum on combiner and reducer. It is working perfectly. Now if I want to find out the average, so the logic for the average, say average, and I just want to find out the average of these particular numbers. Okay, so perfectly fine. We are having 4.8 average over here, 2.25, 2.5, and 2.5. This is the average with respect to these particular numbers. These particular numbers 16, and the average is like this much. Now what we are going to perform, we are applying the same logic over here. So average of what? Average of these particular numbers. So average is 3.635. Okay, average is 3.635 if we are calculating the average. But over here the average is 3.625. 3.625. Just have a look over here. If we are having these particular numbers, the average is 3.625. That is the actual average. But if we have applied the reducer logic onto the combiner, then we are getting 3.635. So we are having the wrong output at this moment. At this moment, what we are having wrong output. So what I can say over here, we just need to like use our mind in order to apply the logic. It can work in most of the situations. Okay, reducer logic, if we are going to replicate the reducer logic onto the combiner side, then it will work most of the cases, but it might be possible on certain cases it is going to provide the wrong output. So being a developer, we just need to use our mind before replicating the reducer logic onto the combiner, right? So with the help of this particular example, I'm trying to say that reducers and combiners both are working onto the same logic, or combiner is working onto the reducer logic, but that is, you can say, utilized by using our mind. We just need to do certain changes over here so that we will be able to get the required output. Okay, fine.
Yes, Ashok.
Clear.
Perfect.
Yes, yes.
Combiners, reducer logic on combiner. Okay, then what we are having, say, without or what I can say, reducer less job. Okay, yesterday, although yesterday we have seen that particular example. Say we are having certain data, say ID, name, and the category, and we are having certain amount. And say ID, what I can say, 1, 2, 3, 4, 5. These are the, say, IDs what we are having, and name, what I can say, Gaurav, Pankaj, Rohit, Das, Harry, Om, Radha. So we are having certain names with certain IDs, or what I can say, customer ID, and they have like purchased in certain categories. Say book, and then say cloth, electronics, and say gadgets. Okay, and let me replicate these particular categories. Okay, and say cloth. Okay, so we are having certain categories and a certain amount spent, 200, 300, 500, 4,000, 2,000, 1,800, 1,900, 2,000, 100, 1,000. So from this particular data, I just want to find out like the person who has, or I just want to find out the person who has spent greater than 5,000, 500. Person person spent greater than say 500 rupees. 500 rupees. I just want to find out that particular number. So say this is given to say mapper one. Let me try to color this. Mapper one. Then what we are having say mapper two. Then say mapper three and mapper four. Okay. So M1, M2, M3, and M4. Okay, so what we are going to see over here. So this particular on this particular data, what we can have just like we just need to check person spent greater than 500. So over here we just need to check like from this particular data, person spent greater than 500. So over here say Rohit 500, that will be the outcome. Rohit 500. Over here, Vikas and Harry both have spent greater than 500. So, or greater than equal to 500. In order to be more specific. Okay, Harry that he has spent 2,000 over here. Then Tom and Radha both have spent greater than 500. Okay, Radha then 2,000, 1,900, 2,000. And then Geeta, she has spent greater than 500. So that will be the output. This is the output from Mapper. Mapper output. Okay. So do we need reducer over here? Do we need further calculation on top of this particular data?
No.
No.
No. So what we can say, this is nothing but reducer less job. And these particular job, these types of these jobs are more performant if we are comparing it with the reducer job. Okay, because over here no shuffling is there. Shuffling of records, that is increasing the cost, that is nothing but the latency over here. So we just need to think in this particular way. Do we proceed with reducer less job? If not, then can we write down the logic in such a way that the maximum work is done over here towards the mapper side and less amount of data is shuffled towards the reducer, so that the shuffling and sorting will be very less, will be happening on very less amount of data, and finally less data is given to reducer that is working onto the monolithic way, and we will be able to get the outcome with low latency. And that is the job of big data engineers, okay, in order to minimize the latency of a particular task. And just have a look over here. Okay, so those particular things I tried to capture in the slide pack as well. So say what we are having certain keywords, and that is having say dog, cat, mouse, dog, cat, dog. So that particular data is splitted in terms of blocks. These particular blocks are, you can say, then mapping is done. This is the example of word count program. So dog, cat, and mouse. So this is the output from mapper. So splitting is done, and then it has mapped one with each and every word. That is the outcome of mapper. Then shuffling is happening. That is like the cat is like shuffling. That is nothing. The data is transferred among the different, you can say, machines. And then what we are having shorted the data. So cat, dog, duck, and mouse. And then finally it is given to the reducer, and reducer has worked in that particular way, and we are able to get the final output. So that is nothing but mapping, shuffling, sorting, reducing, and merging. That is the simple, you can say, flow of data which is happening in the MapReduce. In the another, you can see diagram, what we are having a file that is having certain format that is given to splitter. Splitter has splitted this particular data in blocks, and then it is given to reducer, record reader. Then record reader are going to assign key and value pair. And then what we are having mappers. Okay, mappers are working onto that particular data and providing the output in key and value pair. What we are having then partitioner. Partitioner is going to decide like which key is moving to which reducer. Okay. Okay, then this is like shuffling is happening over here. Shuffling, say the data is transferred from one node to another node. So shuffling of record will happen. Then sorting will happen, and then reducer is like working on to that particular data. And finally the data is given in key and value pair, and that particular data is having certain output format, and then finally it is moved on to the disk. This is nothing but the storage. Like data is taken from the disk, and then it has written onto the disk as well after performing the operation, right? So this is the detail, you can say, diagram what we are able to see the flow of a particular map reduce job. Fine so far, huh? All of you just have a look on this particular diagram and ask if you are having any doubt, huh? All of you friends, all of you.
Ashok,
Mhm.
in one node, mapper and reducer lies on one node only. In node
In
one,
mapper
same
and
lies on the same node before suppling. Where suppling is
uh,
not suppling.
that is not the case, huh? It might be possible like one reducer, the node, like after performing the task, that can be converted in reducer, huh? Like all the nodes can utilize one node as a reducer.
Oh,
Okay,
okay.
that is
And
decided
sub.
by the Hadoop itself, like which node is going to work as a reducer, huh?
Hmm,
Okay,
okay.
we can choose the number of reducer, how many reducer we want to have it for the execution of our application. But on which node, even like we are not going to decide on which node this particular map record block will move. Okay, it is also decided by the Hadoop itself, huh? We are just providing the file, and we are writing down that this particular file will work in this particular way. And like we can think with respect to the processing of data, but machines and all that will be decided by the Hadoop itself, right?
Right, right,
Or named, or what you can say, huh? That is the master of the cluster, right?
right. Because in this figure it shows that during suppling time only node changes. Otherwise, all the things happened in the same node.
Hmm. Hmm, hmm, hmm. Now I'm giving you one more example, uh, and you need to tell me, do we need a reducer over here, or can we proceed without reducer? Huh? Okay, so I'm having certain say users, say YouTubers, what I can say, YouTubers, certain YouTubers are there, and then I'm having certain follower count, follower count. So say YouTuber one, I'm mentioning the IDs, say YouTuber, or there are certain IDs, okay. So these particular YouTubers are there, and I'm having then certain follower counts at 30, 20, 100, uh, 5,000, 200, 140, okay, then 13,000, okay, 1,500, 200, 2,000, then 1,200, 100, 200, 300, 500. Okay. What I want, you need to provide me the list. You need to provide me top 3 followers from this particular data. Input, or you can say expectation, top 3 follower, top 3 users. Uh, top 3 followers basically, or top 3 YouTubers but having highest number of followers. Okay, this is the expectation, and what I what I'm having say 1 lakh record, and I'm running with say 5 node cluster. You need to tell me how this particular operation will be performed. Try one by one, and don't think it will be right or wrong, just try to, I just want to hear from you, like what will be your approach in order to solve this particular issue. You are having a challenge, and I want you need to solve, so how you need to solve this particular challenge, hmm tell me friends,
Can we do it? Can we
hmm
do it first by sorting the follower count and then
hmm shorting the
first
follower count,
sorting the data?
hmm
Yes.
but you are having 5
Lower to
nodes,
highest or
you
maybe highest.
just try to think, you are having 4 node. If you are going to short, then how it will work in case of 5 nodes,
Um, but
hmm
if I randomly assign first three to one node, next four to other node, there
hmm
might be two of the accounts in one node having the highest number of or greater number of followers. So Or maybe the same node can have all three YouTubers having highest number of followers. So the sorting will be still required, I think.
Hmm. 5 node plus 1, 2, 3, 4, 5. So I need to have certain more records. That is fine. Shorting will be required. So what we are having 5 nodes over here. Say mapper 1, mapper 2, mapper 2, then mapper 3, mapper 4, and mapper 5. So what I have assumed, okay, so 1 lakh records are there. What I have assumed that like 20k records are given to this particular machine, 20k records to this particular machine, and 20k this, and the remaining 20k that is given to mapper 5. So how the normal functionality will happen over here? I'm trying to find out the top 3 followers from each and every machine. I'm going to find out top 3 from each and every machine. From each and every mapper, I'm just going to find out the top 3. So say user 130, 1 comma 30, and 3 comma say 100, and 4 comma 5000. That is the output from the mapper 1. This will be the output from mapper 1. Okay. Now, in the same fashion, what I will have 5, 200, then shorting, and then like I'm going to identify top 3 records. So 7, 140, 7, 140, and 8, that is 13,000. This is the output from the mapper2 machine. So I'm going to identify top 3 from each and every machine, and this particular intermediary output will be given to the reducer as an input, and then like all these particular data will be further sorted, and I will be able to identify the top 3, you can say, user from that particular data. Just have a look. So over here, 9 1500, 9 1500, then 10 2000, and 11 1200. So that is the output from okay. So 10 2000 and 11 1200. Okay, this will be the output from the the mapper 3. Yeah. In the same fashion, like all three records will be, because this is having say three records only what we are able to see over here. So these particular three records will be taken as output from the mapper 4 machine. 200 and 500. Okay. So this is the output from the mapper 4 machine. In the mapper 5, what I will be able to get, 2000, 3000 and 1500. So 17, 2000, that is the highest you can say record. Then 19, 3000, 19, 3000 and 20, 1500. Okay, in this particular way, what I will be having, I will be having three records, three records from, or top three records from each and every mapper. So in this particular case, in order to like find out the top three YouTubers, what I want to have, I want to further short this particular data. Okay, and if I need to have one more step, then definitely I need to have reducer. I can't like perform, I can't get the top three YouTubers from the entire data at this particular point of time. I can get top three from each and every machine, that is perfectly fine. Okay, that is perfectly fine, I can get top three, but it is not like say 130, 3100 or 45,000. This is the final output. I need to further check it with the another machine. Another machines can have, another machines can have the data like which can be the highest. So it is written in a typical way. So 5, 4. So these are the three records over here. This is, let me try to mention in this particular way. And 7140. Yeah. Okay, so in this particular way, what I'm able to get top three records from each and every mapper, and these particular mappers are going to provide the output to the intermediary output to the reducer. Then the reducer will work onto this particular logic further. It is going to take this particular data as an input, and then sorting, and sorting will happen, and then top three records, top three users will be selected which are having the highest number of followers. Fine. So the main thing is that these particular task, this particular task is requiring a reducer. We can't move with reducer less job over here. We must have a reducer, and that is depending upon the task that we are going to perform with the cluster. The main thing is that we need to have a reducer, or do we need, or is there like we can proceed without reducer. That is depending upon the operation that we are going to perform. The main thing is that we must try to perform the maximum task over here so that less shuffling will happen. If we are not like moving with this particular process, if we are not performing this much of operation over here, or if we have performed the outcome or performed the operation in such a way that like just small calculation or small operations has performed, then at that moment most of the data will be transferred from mappers to reducer, and then the reducer will be working on heavy data at that moment, and that particular job will be will be having high latency. Yeah. So we need to think in this particular way that reducers will be having less amount of data. We can't avoid reducer in certain cases based upon the data or operation that we are going to perform. So we must have a reducer at this point of time. All of you, is it fine? Are you able to get?
Yeah, sure.
Fine. So we just need to find out top 3 followers from each and every machine, and then we need to have a reducer, and that reducer will work on to the intermediary output, and then finally we will be able to get the final output. Final output. Okay. So that is the case. So example with reducer. Okay. So these are the certain examples in order to give you certain insight how the mapper and reducers are working in a particular job in a map reduce flow job flow, how the data is being divided among your reducer among mappers, and then it is like it is the mappers are working on to top of that particular data. Then we will be getting the intermediary output, and that intermediary output will be for like aligned with combiner and partitioner, and then it is given to reducer, and reducer will work on top of your data, and you will be able to get the final output. You need to have a reducer or not, that is depending upon the work that you are going to perform with that particular data. Okay, so these are certain examples, what I was trying to explain. Now now what we are having, in order to understand the map reduce flow, we need to have three main things. Okay, or this particular map reduce code is written in Java. Okay, so Hadoop is like written in Java, and if you want to perform the operations with MapReduce jobs, then you need to write down the code in Java. But like nobody is writing down the mapper and reducer code in Java. Like we are having certain applications which are working on to top of the Hadoop, and those particular applications take the input, and then take the input in terms of a command, and that particular command will be working onto the cluster, and at the back end it is going to convert that particular command into the Java code. So that is happening in the industry nowadays, and nobody is writing down the code in Java. Second thing, like Java is not a mandatory, you can say, language. Okay, Java is not required for our course module. In order to understand the map reduce functionality, we are just going with certain use cases. Those are written in Java. We just try to import those particular uh, Java programs or Java applications, and then we will try to run in order to get the insight, in order to get like how the map reduce is functioning. So don't focus like how we need to write down the code in Java language. Just try to understand the logic. Like say you are having mappers, like the code is given to mappers, then mappers are working on top of your data, then finally you are having reducer is taking the input from mappers, and then you are able to get the outcome. So I'm going to explain. So what we are having, MapReduce code, and that is written in Java. And once we are going to take the benefit of MapReduce, then we will be having three main jar files, or three main Java application, three main files we need to have. So main, mapper, and reducer. Okay, if we need to work onto the MapReduce functionality, then we need to have three main jars. Let me show you these particular things. So over here, this is Cloudera Quick Start VM, and then this is, say, this is like once you are going to open the Eclipse, that is the ID, which is, let me close this and provide you the details from the starting. Eclipse ID is placed on your machine. You just need to double click on that particular ID, and it will be open. Now what you need to do, you just need to create a project, a file, new, and a Java project you need to create. You just need to give a name, say word count, and then next, finish. Okay, so word count program, the project has been created for you. Now what you just need to do, you just need to import some files. I'm going to provide those particular files. So over here inside my share folder, some files are available. So main, reduce, and Java. So main Java, map Java, and reduce Java. Okay, these are the files that I'm going to provide, these particular files. And what you just need to do, you just need to import these particular files. I will guide you like what is the content of these particular files. So these are the files that you need to import. So you can perform drag and drop as well. Copy files. Okay, perfect. So what we are able to see, though these particular files are available, and if you are going to open these particular files are having certain code. Okay, so main is having main.java. Okay, so this is the Java class, and what I have mentioned, like once you are going to write down the code for MapReduce, you just need to have three Java files, so Java applications. Main is having the main portions where you are going to mention the dependencies and all, where you are going to mention say if the application is executed successfully, then what will be the outcome, or where you are going to, which files you are going to import. Mappers, this is going to have the mapper logic from the developer's perspective, like mappers and reducer, these are the two files where the developer is going to write down the logic. Main file, that is, you can say, the having the boilerplate code. You just need to like import this particular file, do a little bit change, more, no more change is required over here. Okay, so this is like copy and pasted as it is. Okay, but the from the developer's perspective, mappers and reducer, these two files are very important. And over here the actual code is written, actual logic is written. So let me first open the mapper, you can say, file, and then walk you through with the mapper one. So map and mapper is having this particular code. Over here what we are able to see, like different errors are there, and because like we just need to import certain jar files. Okay, so just have a look. I'm just going to copy this particular code and you just need to pay attention. So I'm going to explain mapper. Mapper class basically. Mapper class. So mapper class, and inside the mapper class what you are able to see over here, certain imports are there. Import org.apache.hadoop in tritable. So this is a data type that you are going to import. Now inside the Java, okay. So this is nothing but the Java IDE. Eclipse is nothing but the Java IDE, and we are writing down the code for Hadoop. So for Hadoop, we just need to have certain libraries which we need to import, or certain dependencies that we need to import. And then this particular code will work. With respect to the data types, those are there in Java. Java versus Hadoop data types. So there is a little bit difference in Hadoop data types and the Java data types. If we are having integer in Java, then in Hadoop that is int writable. Int writable. Int writable. If we are having say long, so inside the Hadoop, say this is Java and this is Hadoop. This is from the Hadoop side. Hadoop. So if we are having long over here, we are having long writable. Long writable. Long writable. If we are having float over here, then what we are having float writable. Float writable. If we are having double, then double writable. Double writable. Over here boolean and boolean writable. Boolean writable. Text, that will remain same in Hadoop as well. Text. Then if we are having array over here, then array writable. Okay, so this is nothing but say like we are having certain data types in Java, and corresponding to these particular data types we are having Hadoop data types. So this is the Java IDE, and if we are going to write down the code for Hadoop or MapReduce, then what we need to have, we need to import these particular data types. In order to import these particular data types, we need to have certain jar that we are going to import. So from those particular jars, say we are going to import int writable, long writable, text. So these are the data types what I'm going to utilize, and I'm going to import mapper. Mapper, that is nothing but you can say inbuilt class that we are having, and or inbuilt class, and I'm going to import that, and I'm going to inherit the properties, inheritance, I'm going to inherit the properties of that particular class in order to write down the mapper function, if in order to write down the mapper code. So these are certain import that has been imported, and now like the actual, you can say, execution will start from here. So public class map is the file name of your file name. So this particular map class extend to mapper class, that is the system defined Okay, Hadoop defined inbuilt class. It is inheriting the properties of this particular class. Map is inheriting the properties of mapper class, that is the inbuilt class. Now over here, just have a look at long writable and text and long in writable. So first two keywords are nothing but the input to this particular code. This is nothing but key and value. Mapper is going to take input in key and value pair. Just try to focus over here. Mapper is going to take input in key and value pair and providing output into key and value pair. So first two you can say data types, long writable and text. Now long writable and text. So over here long writable and text. So in the previous session what we have seen, the input to the mapper. So input to the mapper. Just have a look over here. The input to the mapper is this one. Like we are having blocks. This is the input to the mapper. Sorry, input to the mapper is this one. A record reader is like going to assign a number. So that is the random number and the block information, random number and block. So this is nothing but a long keyword. This is nothing but long data type. Okay, it can be like integer is having certain limits like 31,236 to 31,237. So that is the range of integer, but this particular like the key can be very long. So the long writable data type has been defined long, and this is nothing but a text. Okay, so that is what we are able to see over here. So long writable is the input. You can long writable and text, that is nothing but the input, and text and in writable, that is nothing but output. So you can think input to the mapper, input to mapper, that is nothing but this one. This is input to the mapper. Input to the mapper. This is the long data type, and this is the text information. Text data type, and this is string information, that is nothing but text. So over here what we are having, long writable and text. And then what is the output from mapper? Output from mapper, the output from mapper is what? This is the output from mapper. This is the output from mapper. Okay, this is output from mapper. And if we are like going through, if we are having a look of this, so the first one is text and second one is the small, you can say range, as that is integer value of small range. So int writable is the data type. So long writable and text, that is the input, and text and int writable, that is the output. So over here with the help of these first two, you can see data type, these are denoting the input, and second two data types are denoting the output. Now what we are going to say, we are going to map it to what? Long writable is nothing but the key. So this is the key and the text is the value. Long writable is the key and text is the value, and we are defining one, you can say parameter, that is context, or variable, that is context. Okay, so it is going to store the output. Context is defined in order to store the output. So what we are able to see, long writable, that is key, text, that is the value, and forgot this particular word if like we are getting the exception, so interrupted exception. Now the logic is over here in these four lines. So up to so far what we have seen, input, and we have assigned key and value pair, and we have defined a variable that is going to store the output. Okay, now string line, that is value to string. So what we are having, we are having this is nothing but the Hadoop like data type. So it is going to read the data in long writable. It is reading the data in in text information, that is text. So text is nothing but the Hadoop data type. So if you need to convert, okay, if you need to convert this particular data, so over here I have mentioned in wrong way. This is nothing but string. Okay, so we are getting the data in text. This is the text. And now we are writing the code in Java. So what we have done, we have imported the Hadoop data type first. And now if I need to write down the logic in Java, then what I need to do, I just need to convert this particular data into Java data types. So string line, so I'm defining a particular variable that is like the line that is of string type, and what it is going to do, it is going to convert value. Okay, text is nothing but value, and value is going to convert to string. It is going to convert it into string. String is Java data type. It is going to convert this particular value, okay, into the string, and it is assigning it to a keyword that is line. Okay, and okay, so this particular line that was of Hadoop data type, okay, this particular you can say line that was initially, or this particular value that was initially text data type, and I'm going to apply the logic in Java. So I need to convert this particular block of information into Java understandable format. Then I will be able to apply the Java logic. Then onto this particular line, I'm going to split it. I'm going to split it based upon space. So we are going to split it. That's what we have done in our yesterday's session. So splitting will happen. Splitting is going to convert this particular line into words. Okay, so it has defined a particular, you can say, variable, or it has defined a particular array of word basically, and it has given a variable name word, and it has like saved all the words into this particular word, variable word. After splitting, like these particular words are given to this particular variable word. So we will be having array of word. Now we are having array of word. So array of word, and what we need to do, we just need to fix one with each and every word. So string word, I'm going to take I'm going to, you can say, pass this particular, you can say, array of word, and I'm going to uh, assign one or fix one with each and every word. So just have a look over here. I'm having word. Let me copy this particular step. What is happening over here? I'm having array of words. Array of words. Array of words are array of words are there. Then what I'm going to do? I'm going to iterate this array of words. Okay, I'm going to iterate this particular array of, say this is like this. I'm having array of words. It will be like this. Say hello. It will be like this. I'm having array of word. At this moment, after splitting, I'm having the data in this particular way. Let me try to explain. So hello, how are you? So initially we were having this particular data. Try to understand now. So initially we were having this particular data. Initially we were having this particular data, and this was in text format. Okay, data was there in text format. Then it is converted to Java understandable format. Format. Then splitting is done. Split is done. Splitting of line into words. Okay, so I will be getting array of words. So hello, how are you? That is given. It is converted to Java understandable format over here. Just have a look. So value dot toString, so data type has been changed over here. Then this particular string information is splitted into array of word. So split function line dot split and splitting based upon words space. So we are getting array of words. Now we are having array of words. We are having array of words. What we need to do? The next step is what we just need to fix one with each and every word. With each and every word. So what I just need to do, I just need to perform this particular operation. Hello one, say how one. I just need to perform this particular operation in order to get this particular outcome, because my next logic will be working in this on this particular data. Reducer will be working on this particular data. So this is array of word. Now what I'm going to do, I'm going to define a particular variable named as say word. Okay, and I'm going to iterate this particular array of word. I'm going to iterate with respect to array of word. And what I'm going to do over here, I'm going to utilize the context which I have defined onto the top. I have defined context, that is nothing but the output variable. Onto this particular output variable, I'm going to write new. Okay, and I'm going to take word. I'm just forgot about this text and writable. Okay, so I'm going to and new as well. Okay, what I'm going to do, I'm going to write word. I'm going to take say one hello. I'm going to take word like onto the first iteration it is going to take hello and it is fix one. Onto the second iteration it will take how and it fix one. On third iteration it will take r and fix one, and fourth iteration it will take u and it will fix one. So it is going to fix one with each and every word which is given in array of word. Now this particular output what I'm getting over here, that will be in Java understandable format. That is in Java, because this is nothing but a string and this is nothing but an integer. So what I need to do, friends, I need to convert it into Hadoop understandable format. In order to convert it into Hadoop understandable format, what I just need to do, I just need to utilize a very, you can say famous word, new, that is a function over here in order to convert it into word. So word is converted into text, and then this particular integer, I just need to convert it into string integer int writable new and int writable, and then I will be able to get the final output. So because of this, like I was having word in string information, because over here the functioning is happening in Java, and I just need to convert it into Hadoop understandable format. So word is converted into text, and this one that was in Hadoop Java understandable format, that was integer, so it is converted into int writable. So this is the logic for mapper, right? Just have a look and ask if you are having in doubt. You just need to focus on to the logic. No coding methodology like what we like how we are like going to write down this particular code and all. Just try to focus onto the logic, what is performed in this particular logic. Input is given, output is input data type, output data type, then key and value pair, and one variable is defined for output. Then like data is splitted into the lines are splitted into words, and then on words we are fixing one. And as we need to like provide the output to the reducer, and reducer is able to understand the Hadoop data type, so that particular integer is converted into iterable, and a word that was of string type, that is converted into text information. That's it. That is the mapper class. Anything that you are not able to understand with respect to logic?
Understood, sir.
Perfect, Vandana. Pankaj, Rohit, Gaurav.
Understood. Logic
Yeah,
is
clear,
understood
sir.
already.
Logic is fine, huh?
Logic is fine. No issues with logic.
Okay. So this is nothing but the mapper's logic. In the same fashion, what we are having reducer logic. Let me open the reducer jar, and okay, so this is nothing but the reducer jar, Java file. Sorry, not jar, but the Java class. And in the same fashion, what we have seen in mapper, in the same fashion we are having the code for the reducer file. So certain imports, that is perfectly fine, and this particular reduce class is extended to the reducer, that is it is going to inherit the properties of this reducer class, which is system defined or inbuilt class. Now first two are nothing but the input, and the next two are nothing but the output. So these are input and these are output. Same like what we have seen in mapper class. It is going to accept input in key and value pair and provide the output in key and value pair. In the same fashion, what we are having in reducer class, it is going to accept the input in key and value pair and provide the output in key and value pair. Now just try to pay attention over here. So what is the output from mapper class? The output from mapper class is this one. This is the output from mapper class. Or mapper basically, not I'm not going to confuse you. This is the output from mapper. Output from mapper. Output from mapper. Okay. And what is the output from reducer? Reducer. Okay. Output from reducer is this one. This is the output from reducer. Over here. Let me copy and paste it. This is the output from reducer. Now just try to focus onto this particular data. So this is nothing but key and value pair, key and value, key and value pair, and this is also key and value pair. Now over here we are having say 1 1, we are fixing 1 1 1. So this is nothing but text and iterable. We can take it as integer, text and integer, or string or integer. In if you are talking in Java terminology, this is string and this is integer. But if we are talking with Hadoop terminology, Hadoop data type, this is nothing but text and this is nothing but iterable. So this is input to the mapper, input to the reducer. Output of mapper is given to reducer as an input. just have a look over here. Mappers, just forgot about combiner and partitioner. So mappers are giving output, their output to the reducer as an input. So over here, what we are having text, like text and in writable, that is nothing but input. Or this is nothing but the mapper's output. Now what we are getting, the output from map from the reducer, so that is nothing but text, and it can be int writable or long writable. We are not having the information, say like we are having huge amount of data, we are running with say uh, 4 million records, and we are not having the information that big is say up to 30,000, 40,000, or it is coming in billions. So we can have the big number for this particular value. So this is nothing but key and this is nothing but value. So because of this particular reason, what we have mentioned, the output like that is text and long writable. If you are sure that the output can be accommodated with integer writable, that is having a small range, so you can have the int writable as well over here as an output, you can say variable, or output data type, sorry, not variable, data type. So first two are the input data type to reducer, and second two are the output data type to reducer. Then what we are going to do, we are going to perform the task, public void reduce, and text, this text is the key, and int writable, okay, that is nothing but value, iterable, int writable, or iterable, because like what we are having multiple, we will be going to perform sorting and all, and we will be having multiple keys with same values. So because of that, iterable is mentioned over here. But the main thing is that this int writable is value, so this is nothing but the key and this is nothing but the value. And in the same fashion, what we have defined in mapper, over here we are defining a context, that is nothing but a output, an output variable. Now what we are going to mention, we are going to mention account long, and we are going to define a variable that is of long type, long data type. We are using Java over here, so long is the Java data type, and initially we have defined count 0. Now what we are going to do, we are going to work on to the values, keys are fixed, we are going to work on to the values, and what we are going to do, we are going to pass the values, okay, we are going to pass the values, and we are going to work, say if like the count was initially 0, then count plus count dot value dot get, with respect to each and every iteration, it is going to take the value and perform the sum, and we will be able to get the value for each and every key. For each and every key, let me provide you in this particular way. So what we were having, what we have seen, so the data was given in this particular way. So this is input to the reducer, input to reducer. So this is input to the reducer. Like after the sorting will happen, and what it will do, I'm just going to take the example of big, okay, it is going to keep the key and work on to the value. So value, so value over here, what is, what we are having, it is going to do the updation in this particular way, say big, it will be mentioned in this particular way, big 111, okay, it will be working in this particular way. So what we are having, we are having, this is nothing but values, this is the key and these are the values what we are having, key value. So now what we need to do, we just need to iterate these iterate with for loop on these values, and I'm going to iterate with for loop, and with each and every iteration I'm going to add with this particular count which is set over here. So we have set a variable count. Now iterable value, okay, that is going to iterate with values, and count equal to count plus value dot get. So it is going to get the value. Say count was initially say 0, and what it will do, 0 plus 1, okay, in the first iteration what it will get, 1. So the count is set to 1 at this moment. Then the second iteration of for loop will be there. So count equal to count, what it will be, so say count equal to count plus 0 count plus, sorry, count is nothing but count plus count value dot get. Okay. So this is, we are going to iterate with for loop. So count equal to 0 plus 1. So count is set to 1 at this moment. Now count is 1, and now then it is on to the second iteration count. That is going to do what? Count equal to 1 plus value dot get. Value dot get. What is the value over here? 1 value. So count at this moment, what it will be? The count is 2. So this is nothing but second iteration. On to the third iteration, what it will do? Third iteration. So what it will do? It will take count, and count equal to 2 plus value dot get 1, and what we are able to get, count equal to 3. So count equal to 3 with respect to this particular big, what we are having count 3. So we are getting the value 3 at this moment. Big, that is the key, and value 3. Now what we are having, this particular value key, that is nothing but we are taking the key. So that is already in Hadoop data type, like it is in text format. But this particular value, what we are having, this particular value is nothing but in integer format, or long format, sorry, long. So what we need to do, we are just going to change the data type of this long to long writable, because we are going to provide the output from reducer, and it is going to accept the input in Hadoop data type format only. So the count is changed to long writable, and then we will be able to get so text and writable, text long writable, that is nothing but input and output, and it is going to keep the key and work on values that we are able to see over here. Fine. Is it fine? Are you able to understand the logic for reducer?
Yes, Ashok. The logic for this is okay, but if suppose we are doing other functions, other operations, so every time there will be a new program to map this, or there is any API which is working there.
So what I used to say, for mapper, combiner, partitioner, and reducer, these are working on our logic. If we are working with MapReduce, then we need to write down the logic for these four persons. We need to provide, you need to do this task. You need to proceed in this particular way. And what we are learning, we are just trying to learn how MapReduce is functioning in in Hadoop. Okay, we are not supposed to code in MapReduce. Okay, we are going to understand the flow, how the things are working. Nobody is doing coding for MapReduce nowadays. We are having certain high level languages or certain queries we are going to run. So what exactly say I'm having Hive? Hive is going to do, Hive is going to over here we are writing SQL like queries, SQL like queries, and these queries will be converted in Java code at backend. Okay, so we will work with Hive. We will learn how to write down the scripts in Hive. That will be SQL-like queries. At the back end, once we are going to fire this particular query, it will be converted in Java code. So I just want to give you a flavor or feel how the things are happening at the back end. If I'm going to like give you the knowledge of Hive at the very first day, then you will not be able to get like what is happening at the back end. Okay, we are writing the SQL, say if we are writing SQL queries, how these particular queries are functioning, how like the mappers are being generated, how the reducers are working. We will see mappers, reducer, all of things over there. So in order to build your base, I'm giving you the the feel like how to write down the code in Java, and then that particular Java code will be executed onto the cluster. Even like we are not going to utilize Java in our learning journey. We are just going to take a feel like how the MapReduce is functioning internally, right? So
Right.
developers, it's the developer responsibility based upon the task that he or she is going to perform. Based upon that particular task, the logic will be changed over here, right? Fine so far?
Right, Ashok.
Fine, Ashok.
Perfect. Perfect. So this is with respect to the reducer. Now we are having the third class that is utilized in order to have a map reduce job execution. That is nothing but the main class. And what I used to say, this is nothing but the boilerplate code. Main class. Over here, we are having, you can say, maximum things which are, you can say, just we just need to perform copy and paste. Like we are importing certain libraries. Okay, then what we are going to define, we are going to define the main class, and over here inside the main class we are going to perform we are going to map the things that are defined. Say job set mapper class, this is with respect to the mapper class. Then job set the reducer class, so this is with respect to the mapper and reducer class we have defined. Then combiner class, if you are utilizing combiner, over here we are providing the input path as an argument, input path and output path as an argument. Then over here, like what we have seen, file input format, add input format, input path, output format. So input and output format is being defined. And what we are able to see, if return job dot wait for completion true. If the job has been executed, then it is going to return 0. If job is successful, then it is going to return 0. And if it is unsuccessful, then it is going to return 1. Okay, so over here we are going to change a little bit things. Say we just need to change, if like we are going to over here, like we are going to define set combiner class custom combiner. So custom combiner is the class name that you are going to define. Map class, this is the file name for map class. Reduce class, this is the file name of your reducer class. Just have a look. So map, reduce, and custom combiner. Map reduce, let me show you the map and reduce. So map is nothing but the main class for mapper. Reduce is nothing but the main class for reducer. So you just need to map these particular details inside the map class, main class. So this is maintained, this is mapped over here. If you are using combiner, then you need to utilize the combiner as well. The combiner class, you need to mention the combiner class over here. This is for input and input and output format. Okay, so we just need to do this much change over here in this particular code. If like certain stuff, like say text class we are importing, long writable and writable, these are the data type that we are utilizing in our main and map and reduce class, so those particular class. If we are using say boolean, so we just need to import the boolean uh, writable class as well. If you're using any other data type, so we just need to utilize the import those, mention those particular data type over here, so with respect to these particular settings, and then nothing else, from the main class perspective. This is like the boilerplate code, what I used to say, and it will be having the required data which is mentioned, or required imports which is utilized inside the map and reduce class, or combiner class, or partitioner class that we will be going to see, yeah? Right. So map class is nothing but the boilerplate code. We are just doing copy and paste and changing a little uh, bit things with respect to the data types and the classes that we have utilized, right? Fine so far, friends.
Fine, Ashok.
Yes, sure.
Perfect. So
Ashok,
hmm.
yeah, I'm asking that for every job we have to make these changes in this main Java file, like for data types, whatever we have to use in our logic, those we have
Mm-hmm.
to change every time on this main Java file for that
No,
particular job.
main Java will remain same. Main Java will remain same. Okay. So if we are using something in map class, then we need to mention over here. If we are using in reduce, so we just need to mention over here. We just need to write like mention those particular things once, and it will be utilized in each and every class, which will be utilized in this particular project. Word
Oh,
count, that is nothing but a project.
okay, okay,
Okay, so what you are able to see over here, like uh, import Apache cannot be resolved. If I'm hovering over here, import org.apache cannot be resolved because this is Java ID. Inside Java ID, we have not imported the required jars which can convert, from where we can import these particular uh, things, like where is main class, where is map class, where is reducer class. It is not able, this id is not able to understand. For that, what we need to do, we just need to import certain jars. Okay, so in order to import jars, what you need to do, you just need to click onto right click onto the word count on your project that you have created. Then you just need to click build path. Okay, and then configure build path. Okay, and over here add external jars, add external jars. So let me show you first the jar files. I'm going to share these particular jar files. So in this particular directory, I'm having MapReduce jars, MapReduce jars, and these are certain jar files. Okay, these are certain jar files. What I'm going to, these are the jars what I'm going to import, and just have a look. So Hadoop, SDFS, NFS, these are like the jar files, which will be utilized in order to work with in order to work with the Hadoop in Eclipse IDE. So I'm going to import all of these particular jars, and then you will see these particular errors will be gone. So let me try to click onto the build path, then configure build path, add external jars, and now I'm going to import these particular jars onto say desktop. Inside shared folder I'm having say MapReduce jars. I'm going to press Ctrl A and OK. It has imported all of these jars. I'm going to press OK, setting build path and all. Okay, so building workspace 57%, and just have a look. So almost all the errors has been gone. One error is there, set combiner class. Let me comment this one. Okay, so let me save this. Okay, perfect. Now what you are able to see over here, we have imported all the jars and all the errors has been gone. All the errors has been gone. Okay, so map jars, map and reduce. So we are able to import all the jars, required jars, and then the errors has been gone. Now we are having a particular program. Okay, we are having a particular map reduce program, that is the word count program. Let me try to create a dummy data for this. So file.txt.
Sorry,
So
Ashok, can you please explain the function of jar over here? Why we like use that?
okay, this is similar like if you used Python and like if you want to perform certain operations with pandas, then you need to import pandas library, right? So
Okay,
until so up to so far what has happened, we have utilized say pandas dot import files or save files, whatever, or pandas dot df. We have utilized pandas library, but we have not imported. Okay, if we have you have not imported and you have pasted a code that is utilizing pandas library, then you it will be throwing error.
right,
Okay, so same we were able to see over there. We have utilized the jar files, but we have not imported those particular jars. We have mentioned import jar, but from where we are going to import? Okay,
right. Got it.
so that is nothing but certain jar files. Based upon that, the Hadoop will work, and like we have written certain code who is going to uh, instruct Hadoop that you are going to perform this. Those particular jar files are going to utilize and going to do the execution on top of your code. So so we are having say this particular file, and let me try to and okay, so and let me paste in create a folder, say batch. Okay, batch 32 is already available. Let me Hmm. Okay. So bash 32 folder, this is having a particular file. Huh? Okay. Now what I want, I just want to do the execution of this particular file. And I just want to do the execution of this particular file with the code what I have written in main map and reduce jar file or classes. So what I just need to do, I just need to run configuration. I just need to click on to the run configuration, and I just need to pass the arguments. So pass the arguments, and with respect to the arguments, say so this is the file 2.txt. This is the input path. Let me mention over here. And file 2.txt. This is the input path. Txt. And I'm just going to store the output over here only, and I'm going to give say first execution. Okay, this is nothing but this is an argument I'm going to pass on. First, this is input, and in the second path, what I have mentioned over here, that is nothing but the output path, input path and output path. So I'm going to pass these particular, you can say, variables or arguments, which is going to denote like this is the input and this is the output. And let me copy and paste it over there inside the run configuration. And Java ID run configurations, and I'm going to pass these particular arguments. Okay, main, I just going to browse the word count as a main, and class path source environment, main class, main default package. So I'm going to give the project name over here and the main class name over here. I'm going to pass the arguments over here. Okay, let me apply and run it. Okay, so just have a look over here. Okay, just have a look. Total input file 1. Okay, so just have a look over here. We are going to let me copy these particular logs in order to give you the detailed information. Let me copy these particular logs over here. Arguments, arguments, past while execution, file, file execution. Okay, uh, output logs. Okay, So these are the output log, friends. What logs what we are able to see. Let me walk you through with these particular logs. So what we are able to see, just like total input files one, that is perfectly fine. Now number of splits, number of split one. Okay, so one split is there. So if like we are having one only number of split one, then definitely one mapper will be working. Okay, if we are having a huge file, then multiple mapper will work over here. So then what we are able to see, algorithm version, I'm just trying to say algorithm version. Okay, map percentage, reduce percentage. So execution has been started over here. Okay, like mappers and reducers both are working. So then certain operations, certain things waiting for reduce task. What I want to say over here. Okay, map percentage map has been like executed successfully. Now the reducer is started. Okay, now reducer, we will be able to see the reducer. So map 100%, reducer 100%. So it has been like the job has been executed successfully and completed successfully, and we are having certain counters. And just have a look onto the counters. Okay, so this is the total byte read, this is the total byte return. Okay, what we are having, input records 10, output records 57, and then what we are having mapped output. So certain uh, counters are there with respect to the MapReduce framework. Input groups, shuffle records. Just have a look. Shuffle bytes. Shuffling is what, like once the data is moved among the different nodes. Okay, so this much of shuffling has happened. Although like that is not among the nodes, but among the inside the, with respect to a key, like a key, with respect to the keys shorting and all, the shuffling has happened. Then with respect to the shuffle error, nothing, no error has been there. And output format counters this one, and return is this one. So this is nothing but, like say, based upon the code, the execution has been done. Now let me try to show you the output. So this was the file, and this is the output what we are able to get inside the first execution. And inside the first execution, what we are able to get, the part r then to 5 times 0, that is denoting, like say we are single file, that is denoting, say we have done the execution, only one reducer has been utilized. If we are having, say, multiple uh, partition part hyphen r files, that means multiple reducer has been utilized. Let me open it. So what we are able to see, all is like 4 times. We are having certain blank space. Then big is there 9 times, big data factory 4 times, hello 4, welcome 4, big 5, big dot 5. Okay, data 14 is 4 2 4. So that is nothing but what we have expected, like the frequency of each and every word, the frequency, and it is like it is shorted, all for big, then h, then so not shorted, sorry. So what we are able to see, no, yeah, that is shorted basically. That is first like the capital letters, then we are having small letters. It is shorted somehow. So what, this is the output what we have expected. Based upon the data what we have given, we are able to get the output. And if you are able to recall, this is with respect to our stuff what we have decided in our yesterday's session. So what we are able to see, we have done the execution, like we have a particular file, then splitter is working, then record reader, mapper and reducer. So we have gone through with this particular operation. So what I can mention over here, this is executed successfully. Okay, fine so far. So it has been completed. The first operation is completed. First is completed. Right? All of you. I want buying from all of you.
Yes, yes, Ashok.
Yes, yes,
Right,
Ashok.
right.
Okay. So we are able to get like with mapper and reducer. Now, what we have like reducer equal to 0. Okay. Can we set reducers equal to 0? If we want to set reducer equal to 0, then what we need to do, we need to set one parameter. That is num reduce task. Let me okay. So the second one is what, like the reducer. So over here inside the main class, what I'm going to do, I'm going to set reducer equal to 0. So job dot set reducer, set num reduce task. Job dot set num reduce task num reduce task integer. Just let me try to save this. It is not taking. Task. So I'm going to set reduce task. What I have done, it is like defining, we have defined the reduce class, reducer class, but I'm going to set a property reduce task to 0. I'm going to set reduce task to 0. So let me try to move with this particular configuration. So argument, inside the argument, I just need to change, say, second execution. Second execution. Apply, run. Okay, the execution has been started. And what I have done over here, I have set to reducer to 0. So if reducer is set to 0, then what we will be having, we will be having output from mappers only. Right? All of you.
Yes, Ashok.
Right.
Second execution. and second execution is with respect to this one. These are the logs, and what we are having, second execution set reducer to this is the flow what we want, and for this what we have done, we have set one property, yeah, inside the main class, and that is this one property, yeah. It's very simple, so we have set this particular property. Now what we are able to see over here, reduce 0, map 0 and reduce 0, reduce 0. So previously what we have seen, reduce 100% was there, right? And over here no reducer is there, and then it is going to write the output, so just have a look what is the output inside the output directory, so base 32 and execution, so over here part hyphen r, that is nothing but the reducer output, now inside the second execution what we are getting, part hyphen m, that is nothing but mapper output, part hyphen r, and we are having one mapper only, so we are getting one file over here only, right? And what we are expecting in mapper, what we are expecting as a mapper output, this is what we are expecting, like this is input to the reducer or output from the mapper, right? R1, what
Right, Ashok.
our logic is like splitting the data and fix one with each and every word, just have a look. So the same stuff we are able to see over here, right? And this is as per our logic. Fine.
Fine,
All
fine.
of
Okay.
you.
Yes, yes, Ashok. It's fine.
Perfect. So we are able to get the output from mapper only. How? By setting the property, this particular property, set reduce tasks to 0. So we are able to get a perfectly fine. Now for the third operation, what we are able to see over here, third operation. So third operation is denoting like we are going to set reducer equal to 2. So over here we just need to do the change, do a little bit change, that is like a third execution, so what we just need to do, we just need to set that property, so over here this is the property and we just need to set it to 2. Perfectly fine, so let me do that and set this particular property to 2, and setting is done. Now I'm going to run the configurations, and inside the class path I'm going to mention the third execution. Okay, apply, run, perfectly fine. So once I'm going to perform the execution with 2 reducer, so what we will be having, what I'm expecting 2 reducer file, I'm expecting 2 reducer file. Over here I'm having one, I'm working with one reducer, so I'm having one reducer file over here. But if I have utilized 2 reducer, then definitely 2 reducers file will be there, just have a look. So part r and part hyphen r and 4 times 0, 5 times 0 1, so that is denoting like I'm having two reducers are working over here, and you might be all for 2 4, and over here in this particular reducer, one big, okay. So what I mentioned, like the reducers will be having the unique key. If big is available over here, big will not be available in this particular reducer. Now you need to try to recall what I have explained in previous session. So over here, it is the responsibility of partitioner to decide which key is moving to which reducer. Like big is given to big is aligned in such a way that it will be moving to reducer 1 only. Okay, big will not be available over here, otherwise we will not be able to get the correct output, huh? So reducer or partitioner is working over here internally, and it is deciding like which key is moving to which reducer. Now just have a look. Over here we are having two records, and over here we are having max of the records, huh? So data is not divided equally to these particular reducer, huh? So this particular movement of record is happening based upon the certain logic, okay, certain system defined logic or hash functions, okay. And if you are able to see that this is not optimized in a good way, then you can write down the code for this particular movement, like which key is moving to which reducer, then you can optimize this. So for that, what we are having the next set of operations, like we are going to add a partitioner. Okay, partitioner is going to do, although like partitioner is working in this particular case, but it is working onto the system defined logic. Okay, it is working onto the system defined logic. Now what we can do, we can add a class, partition the class, and write down the logic so that we can further optimize the movement of records among the reducers, right? Let me write it down. So and let me paste the oh, okay, pasting log that is not required, huh? So fourth execution, what I want to say over here, fourth execution, fourth execution, that is this one, third, fourth, and fifth. Okay, this is the fourth execution, huh? This is the fourth execution, huh? So what we are having, partitioner over here, huh? Partitioner is working on certain system defined certain functions, huh? Certain functions, that is what you can say, hash functions, huh? Functions, huh? So if you are defining, let me write it down, if you are not defining the logic for partitioner, then it will work on certain system defined logic, huh? Or if you want to define custom logic, then we are having partitioner class, huh? Partitioner class, huh? Okay, so we will be adding the partitioner class, but I think up to third of execution, that is fine for the day. The fourth and fifth step we will do in our next class. What I recommend to all of you, just try to go through with the recordings and try to set up the environment, that particular Eclipse ID, import the jars, and import these particular code files and try to do the execution up to third step. And fourth and fifth we will do in our next session. I think that will be fine. Otherwise, it
Yeah,
will be
Ashok.
happy all.
Yes, yes. Please share these jar files and this mapper and reducer and main Java file.
Yes, yes, I will share. Not an issue. I
Yeah.
will share. That is
Yes.
on
Yeah.
me. I will share those
Yeah.
particular jar files and class files. You just need to import,
Okay.
and if you stuck somewhere, you can go through with recordings. If you are not able to get through recording, then you can ping me.
Sure. Sure. Sure.
Right?
Yeah.
Perfect. Fine so far, friends.
Yes.
Fine,
It's
fine.
perfectly fine.
Okay. Okay. So let me stop recording and ask